Hello everyone and welcome to a new series of videos for Year 10 Maths. Our focus for the next 4 weeks is going to be preparing for maths methods with some algebra. So in this video we're going to look at something called simultaneous equations. And in this context the word simultaneous just means at the same time. So in previous work, you've been given an equation with one variable, x, and you've been told to solve it. What we're going to do in this topic is I'm going to give you two equations, such as these two. And I want you to tell me the values of x and y that satisfy both equations at the same time. It's not immediately obvious how we would go about doing this, and in this video I'm going to teach you one method which is called the substitution method, and in the next video we'll look at the elimination method. But for now, have a think about what the solution to this pair of equations might be, and see if you can use the method in this video to solve it later. Let's get straight into it. So in our first example, I've given you two equations. The first one is x plus y equals 8, and the second one is y equals 12 minus 3x. Some textbooks like to number the equations, and you don't have to do this, but I personally find it quite helpful, especially when describing what I'm doing to other people. So when I write the number 1 with these two brackets around this, I'm calling this equation 1, and I'm calling this equation 2. And now what I'm going to do is I'm going to substitute equation 2 into equation 1. So wherever I see y in this first equation, I'm going to replace it with 12 minus 3x. So let's go ahead and do that. X plus 12 minus 3x equals 8. And now if I collect like terms, I get 12 minus 2x equals 8, because x minus 3x gives me negative 2x. And now if I take away 12 from both sides, I get negative 4, and hence x equals 2. So now I've found one of the numbers x, and now I can choose whichever equation I like to substitute x into to find y. So I could substitute x equals 2 into equation 1, or I could substitute x equals 2 into equation 2, and I'd get the same solution, y equals 6. I will just write what I'm doing, so I'll say substitute x equals 2 into equation 1 to find y, and now I have 2 plus y equals 8, and y equals 6. So the solution to this pair of simultaneous equations is x equals 2 and y equals 6. Note, I could also have used equation 2 as well. There was nothing special about choosing equation 1, because if I substituted x equals 2 into this equation, I would have gotten 12 minus 6, giving me 6 as well. Alright. One thing I'd like you to keep in mind as we do this work on simultaneous equations is the graphical interpretation. So what I've done in another window is I have graphed the two equations, x plus y equals 8 in red, and y equals 12 minus 3x in blue. And what you'll see in the middle here is the two lines meet at a common point. And the coordinates of this point are x equals 2 and y equals 6. That is the exact same numbers that we found. So in this context, when we have two equations in two unknowns, the graphical interpretation is the solution tells us the coordinates of the point of intersection of the two lines. So we could have drawn the two graphs and looked for the common point of intersection, but that's quite time consuming. And our focus in this unit is to use algebraic methods rather than graphing methods, although I want you to know about how to do it with the graph as well. But from this point onwards, we're just going to focus on doing this with algebra. So if you're comfortable with that, let's move on to another example. So here I've given you two new equations, y equals 16 minus 2x and y equals 8 plus 4x. Now, because these two equations are true at the same time, I'm noticing that I've got two expressions for y, and I know that they have to be equal to each other at the point where the lines meet. So I can therefore write the first expression for y equals the second expression for y. And now I have a linear equation in x that I can solve. I have an x term on both sides. So what I will want to do is perform an operation involving x on both sides of the equation so that I only have one x term left. So what I'm going to choose to do is add 2x to both sides, which will leave me with 16 equals 8 plus 6x. So what I've done there is I have plus 2x on both sides. And now you can see I've only got one x term. To get this x term by itself, I need to get rid of this plus 8. So what I need to do is take away 8 from both sides. And that will leave me with 8 equals 6x. Or x equals 4 over 3. Now I can choose either equation to substitute x equals 4 over 3 into. It doesn't matter which one I pick because I'll get the same answer. Just because I can, I'm going to use the second equation this time. So I'm going to say y equals 8 plus 4 times 4 over 3. And now I've got to work with fractions. I know that my answer is going to be out of 3. So I might as well convert to fractions out of 3. So 8 is the same as 24 divided by 3. And 4 times 4 over 3 is 16 over 3. So my final solution is x equals 4 over 3 and y equals 40 over 3. Let's check if this is true. 16 minus 8 on 3 is the same as 48 on 3 minus 8 on 3, which gives me 40 over 3. So that's good. This is what we want. You might be wondering, do we have to write this? No. But it is a concise one-sentence statement which addresses the question being asked, that is, to solve the two simultaneous equations. So implicit in this example is is a question which says, find the values of x and y which satisfy both equations. Or the question might say, solve these two equations simultaneously. And I've just summarized what we've done in a short statement. And I encourage you to do that as well in your work. All right, we're going to do one more example and then we'll leave it there for the substitution method. Now, I will start with a disclaimer that the elimination method is better. And we're going to do that in the next video. So I kind of want to motivate this by showing you that the substitution method requires a lot of work here. And if we can find a more efficient way of doing this, we should use it. So I'm going to call this equation 1 and equation 2. And it's not immediately obvious what we should do, but our basic approach has been to rearrange one equation for one variable and substitute this into the other equation. What I'm seeing is that equation 1 has x by itself. So I'm going to start by rearranging equation 1 for x. If I do that, I get x equals 11 minus 3y. What I've done here is I've taken away 3y from both sides. And now I can substitute this expression for x into 2, equation 2, and solve for y. So just to recap, I've rearranged one equation for x and substituted that equation into the other equation and solved for the alternate variable. So wherever I see x, I'm going to replace it with 11 minus 3y. So I'm going to have 5 times, so bracket 11 minus 3y minus 2y equals 4. Now remember, when you have brackets, multiplication is implied, and you need to do the multiplication of the outside term by everything on the inside. So this becomes 5 times 11 minus 5 times 3y, which is 15y. And now I take 2y, and that gives me 4. All right, do a little bit of rearranging. 55 minus 17y equals 4, minus 17y equals negative 51. And if you divide 51 by 17, you actually get the number 3. So we've got one number, y. And now what we can do, I'll just draw a new column here. I'll say substitute y equals 3 into the expression for x. So I could put it back into one of these two equations here, but it's actually quicker to put it into this equation because at the end I'll get my value for x straight away. So x equals 11 minus 3 times the value for y which I found previously, which was 3. So it's 11 minus 3 times 3, which is 11 minus 9, which gives me 2. And hence, the solution is x equals 2 and y equals 3. So let's check. 2 plus 9 gives me 11. 10 minus 6 gives me 4. So we know this solution is correct. Now, I claim that there is a more efficient way to do this, and I will show you that in the next video. It will particularly come in handy if there was another number besides 1, which was a coefficient of this first x term here. So if that was, say, 3x or 5x or 8x, this would have become a lot messier, and that's why we might want to go for the elimination method. So I'll show you that in the next video.